Hello and good morning everybody. This is Jana Tarek explaining this lesson, heat and temperature. Let's introduce the lesson. Now, we'd like to introduce our lesson. What will happen if 2 drops of boiled water fell on a boy's hand? Most of you will tell me that this boy should go and put a cube of ice on this part to cool down the skin. But in fact, the ice won't cool down the skin. The skin will melt the ice with its heat. So we'll need to wait till the hand give out heat to cool itself. Now you're all confused, but you are as many of people need to understand the concept of heat and temperature well and many differences between these two quantities. So, what will be presented today is temperature, heat, relation between heat and temperature, heat energy calculation, comparison between heat and temperature, thermal expansion and cooling effect. Now we have experiment 1 on temperature. In this experiment will help us to know exactly what's temperature. If you touched a cup of boiled water and then you touch a cube of ice, observation, the cup of boiled water feels hot while the ice cube feels cold. Conclusion, it's very important to quantify and measure the difference in warmth of objects, and this need tell us the concept of temperature. Now, experiment 2 about temperature also. If we are in a lab, in a science lab, and we have water and we are watching water molecules under a microscope, we'll find out that they are in continuous random motion in all directions, and as temperature rises by heating the water, water molecules move faster and the spacing between them increases, and by letting water to cool down and decreasing its temperature, molecules movement is slower and are more closer to each other. Now we have come to the definition of temperature. Temperature is defined as the degree of hotness and coldness of an object, or the measure of the average kinetic energy of molecules of a system, and it is measured by a thermometer. This is our first fun fact about temperature in water. Water expands and molecules move far away from each other, and as its cooled molecules are closer but from 4 degrees Celsius and lower, water molecules or ice expands. Now we have reached our third experiment about temperature. Let's learn how to calibrate a thermometer. Step 1. Place the thermometer in ice and mark the melting point of ice. Then, place the thermometer in boiled water such that it does not touch the boiling water that shows the temperature of the steam. Observation, the boiling point of water is 100 degrees Celsius, which is marked as the upper fixed point. The melting point of ice is 0 degrees Celsius, which is marked as the lower fixed point. And between these two temperatures, the space is divided equally into 100 divisions, representing degree Celsius. And now we have reached heat. The definition of heat. Heat is defined as the total amount of thermal energy in a substance that can transit or flow from one substance to another when they are in contact according to difference in temperature. We are going to perform now some experiments relating heat and temperature. Experiment 1. Having a beaker containing water and supplying it with heat energy by a flame, the thermometer records temperature rise as the average kinetic energy of molecules increases. Our second experiment. Getting two objects, one at high temperature and the other at a lower temperature, and placing them in contact, heat flows from the object with high temperature to that of the lower one, till both have the same temperature. From these two experiments, we can conclude the relation between heat and temperature. Temperature is directly proportional to heat. Since the temperature is defined as the average kinetic energy of molecules of a system, so when a system or a substance is supplied with heat energy, a rise in temperature occurs as molecules move faster to their average, so their average kinetic energy increases. Heat energy always flows when two bodies of different temperature are put in contact with each other, and it flows from body of higher temperature to the body of lower one, and keeps flowing till both bodies have same temperature, in other words, reach thermal equilibrium. Now we have reached the third experiment, which describes or explains the concept of heat energy calculation. Getting two beakers containing one of them containing 500 centimeter cube of water and the other one having 250 centimeter cube of water, both of them at 25 degrees Celsius, the room temperature, and supplying both of them with heat energy by a flame till each of them reach 100 degrees Celsius. It is observed that the beaker having more water takes more time to reach 100 degrees Celsius, and so Q, which is the heat energy of water in beaker 1, is not the same as that of water in beaker 2. Also, by repeating the same experiment but having two beakers containing same volume but different substances, the same conclusion that heat energy differ between beakers is reached. Now, heat energy calculation. How can we calculate heat energy? From the third experiment, we conclude that each substance has its own specific heat capacity. This is a quantity that determines the amount of heat energy required to raise substance temperature. The mass of substance matters and affects amount of heat energy required. Therefore, the heat energy of a substance is Q equal mc delta T, where m is the substance mass, C, the substance's specific heat capacity, delta T is the difference between the final temperature and the initial temperature of the substance. Now, we have a small comparison between heat and temperature. Heat is the total amount of energy of a substance. Heat is energy in motion or transit, while temperature is the average energy of molecular motion of substance, measure of the average kinetic energy of molecules of a substance. Now we'll discuss the thermal expansion. It is a concept related to heat and temperature, where, as a substance experiences rise in temperature, the movement of its molecules increases and spacing between them increases, and so expansion occurs. And vice versa, when the temperature of a substance decreases, the spacing between the molecules decreases and they are more closer to each other, so the substance contracts. That is why railway tracks, as we see here, have gaps to enable expansion during summer and contraction during winter for the train. And the same idea for the bridge joints spacing. They also have spacing to enable expansion in summer and contraction in winter. Now, our last fun fact about evaporation and how it's related to the cooling effect according to the body temperature regulator. In all human bodies, there is what is called temperature body regulator that makes body sweats when its temperature increases, and so that sweat evaporates, causing the cooling effect. Now, we have reached the end of our presentation. Hope you enjoyed my presentation and hope it explains you concepts and some interesting ideas about heat and temperature. Done by Jana Tarek under supervision of Mr. Sharif Higazi. Thank you.